Well, I made this video for you if you're trying to graph some data from a lab that you did or some other kind of data. And you may have done some of this in an algebra class before, but there's some important things you got to do in science that I think is worth going over here. So I made up some data and I put it up in the corner there in the left, and totally made up, but I just want you to see how we deal with numbers like this. So I've got some length of something that I measured that goes up to 90, and I've got some masses for those things that goes up to 18. So the main thing to know are what the biggest numbers are that you have. And it's kind of nice here because they go in order, but they don't always go in order. But the main thing is to find out what the biggest numbers are. And the first question that you have to deal with is, what numbers go on which axis? We refer to these as the horizontal axis across the bottom and the vertical axis here across the side. And I've given you a hint. Here on the left side, I said the dependent variable name with its units. And so we use words independent and dependent because the way we say it is that the dependent variable depends on the independent variable. So when you have a table like this, you're always going to have your independent variable written first and your dependent variable written second. So in this case, we would say that the mass of our object depends on its length, which kind of makes sense. You wouldn't say that the length of an object depends on its mass. Now, sometimes it's not obvious, and so if you just have a chart like this, just know that the independent variable goes along the bottom axis, and it's always going to be listed first. And then the dependent variable here goes on the side. So I'm going to go ahead and write in my labels. This is called the label for this axis, and its unit. That's measured in grams. And then down here, I would write the length, and this will be in meters. Now, if you're doing a real lab, you're not going to be using these labels. You're going to have to get the labels and the units from your actual data table. All right, we'll have a title, and I'm not sure what title this could be, but this, we'll just call it the mass of objects. Depending on what the lab is, you can just use the lab title as the lab of your graph. So those are just some preliminary things. And now here's the really important piece. How do you decide how to get the numbers on each axis? Again, if you've seen this in math class, sometimes they already do that part for you, so you don't have to think about it. But in science, you might have to set up your own graph like this. So if we look at the mass, which is going along here on the vertical, notice my highest number is 18. So the most important ground rule is you want to start typically at 0 down here in the corner. So I'm going to put a 0 in this box, and that means this line, this very first line that I'm putting my pencil on, that represents 0 mass. And then I need to evenly space out whatever numbers I choose so that I at least make it up to 18. Now, some people think they have to make it exactly to 18, which is kind of a pain. You don't have to make it exactly there, but you want to make it at least to 18. You don't want to make it a huge number like 100 because then all of your data is going to be really low on the graph. So my goal is to make it at least to 18, but not go way, way over 18. So then you think about, okay, what can I number by in these boxes here? And I've got 5 boxes to pick from so that I can number by the same increment each time and make it up to at least 18. So you could try a number. Let's say we'll try it by 2s. I could go 2, 4, 6, 8, 10. But you see, that didn't get me up to 18. But if you know you got up to 10 trying it that way, what if we were to number by 4s? 4, 8, 12, 16, and 20. Well, that gets me up there. But there's a reason I don't like 4s, and that's because notice that each of these boxes has 5 little boxes within it. So if you can pick something that is a multiple of 5, that makes life much easier. So how about we go by 5s? 5, 10, 15, 20, 25. That's bigger than 18, and it's not too much bigger. So that actually is the perfect number to use so that I can fit all my data on there without going way over, and I have easy numbers to count by. Because then with these little boxes, I'm really counting by 1s. If you follow my pencil, 1, 2, 3, 4, 5. And then all the way up to 25. So now can we do something like that for the horizontal axis? I have to make it up to at least 90. What I like to do sometimes is I think about what's the next highest number after 90 that's an easy number to count to. And to me, 100 is the perfect number. So you might want to just stop the video here and see if you can, before I tell you, figure out what you could number by so that you could make it up to 100. So just pause it now and maybe try that. So maybe you figured this out, and it's actually not that bad. If we put 0 down here in the corner, again, now we're talking about this line here on the left representing 0, then I can get up to 100 if I go by 20s. 20, 40, 60, 80, 100. Nice and evenly spaced out, a nice multiple of 5, and gets me up to at least as big as 90. So now we've got our axis set up, and it's the point of what we call plotting the points, or just putting the data points on there. So you go to your very first data point. In math class, they might call this an XY coordinate, or they might call it an ordered pair. Maybe you haven't heard those words before, but it's just the line or the dot where the length is 0 and the mass is 0, which on ours is right there. Just put a nice prominent dot there. And then the next one is where the length is 15 and the mass is 3. So now you got to do a little thinking. If this is 20, what are we counting by? We're actually counting by 4s. 4, 8, 12, 16, 20. So you see where I have my pencil? This line right here is where the length is 16. So 15 is just a little before that. So I'm going to say maybe right about there where my pencil is. And then I need the mass, I said, was going to be 3. All right, so here's where 15 is. And now for the vertical axis, I'm counting up by 1s. 1, 2, 3. Remember, we had different scales for the horizontal and the vertical. So I just put a dot right there, and that's where the length of 15 meets the mass of 3. And in a similar way, a length of 30 and a mass of 6. Now 30 is a little easier to find because it'd be halfway between 20 and 40. So here's 24, 28, 32. Right in between there would be 30. And then I can go up 6 spaces. 1, 2, 3, 4, 5, 6. And that's where my next dot goes. And if you continued this, maybe I'll do one more. Here's 45 meeting 9 right there. And so we're going to get a whole set of dots that match up with each of these data points that we wrote. So whatever data you have, it's a matter of setting up the axis so that you can fit all your numbers on there. You want to make sure you're not going to go off of your grid. Make sure that the 2 units are in the right spot, and then get your dots on there as I showed you here. So hopefully that helps you. Maybe if you've got a graph to do, if you have more questions, you just see me when you come into class. Thanks for watching.